Hi, Leslie Wren, back again with another grading tutorial to help you sort through grading your site for this last exercise. So, what I want to go over today is dealing with sloped paths. Specifically, I'm talking about either having to redo a path or introducing a new path on an existing slope and how you deal with calculating where to put the new contours to put in a slope of a certain percentage. And then later we're going to talk about how to place those contours on the path, either to create a level path or to create a cross slope that would facilitate drainage off to the side of the path. So first, here we go. We're going to regrade a path to create a desired and intended slope. So we're back at this quad on campus, and if you recall, it's currently under construction, under renovation. It's just west of the McCain, but we're going to act like it's just normal, that it isn't a big construction site right now, because we have this nice little example of the topography here for us to work with. So what I want to focus on to start is we are going to look at this path that hopefully my little laser pointer will be popping up in just a second. Yes, there we go. That path right in the middle of our site. So what we are going to do is we're going to pretend that the university has told us that they would like this path redone. And for right now, we can ignore this little spur that's to the side of it. We'll just pretend it's going away. It's not even there. But that path that I circled before is the one we have to regrade, and it has to have an even slope all the way down, which basically that means all of these contours here that are currently kind of evenly spaced, but not quite, we need to place them at even contour not contour intervals. We need to put them even distances, roughly equal distances apart. And so this is how we go about thinking through this kind of problem. So the very first thing is that let's just pretend, for the sake of ease of this problem, that K-State has told us that we are not going to affect at all contours 1067 or this one down here, which I need to mark what that contour is. So I know that I've got 1065 right here, and I'm going to assume that we are moving downhill. So let's see here. I'm going to go ahead and write in this contour as 1064, and that will make this one 1063, 1062, and then this last one, and I'll do it in green, 1061, just to tell me that I'm not changing that one. So I know that 1067 and 1061 are going to stay just as they are, but I'm going to adjust those other contours on site in between the two. So this is what I need to do. Picking a new pen color. Oh. All right. So I have this distance, this overland distance, not the vertical distance, but that right there is my run. And I also sometimes refer to that as my delta L, or my change in length. And I know that over that length, and we'll get to what that is in just a second, I've got to change 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 feet total. Okay. So what I need to figure out is how to space those contours. So the first thing I'm going to do, and because I did not have a graphics skill to plop next to this plan, I faked one, and we don't normally work at 12 scale or 6 scale or 24 scale, I know. But just for the sake of this demonstration, I approximated based on existing site features that I know the measurements of to be able to make this scale. Now, this is also limited by my capabilities in Jamboard, which is the application I'm using right now. Just go with me on this one. Of course, on your own plans, you will use the scale that you have, which is most likely in an architectural scale, 4 scale, 8 scale, 16 scale, etc. So I'm just going to look down here at my nifty little scale. And I know that that distance, 48 feet, I'm just measuring this roughly, 48, 96. This is roughly 99 feet long. Oops. Don't do that. I don't want that to change. Let's see if I can make that go back in place. Good. Okay, so my run is roughly equal to 99 feet. And I know that my rise is 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 foot. So my rise is equal to 6 feet. But that may not come into account just yet. What's more important is that I know that I need to space these evenly. And so I've got, 1 space, 2 space, 3, 4, 5. Okay. Oh, is that 6? So I need to 1, 2, 3, 4, 5. I have those, but I am placing. Well, no, I'm going to divide that 99 by 6. So I'm going to go to my calculator here. 99 divided by 6. So each of those segments, if I were to do it evenly, so the number, oops, that's not what I meant to write. The distance between contours is going to equal 99 feet divided by 6 feet. And that is equal to 16.5 feet. All right, so if I go down here to my scale and I want to figure out what 16.5 is, I have to do this approximately because I don't have it exact, but I'm going to guess that since this is 18 feet, that this is probably 16 feet. I'm just going to say that that's close enough there. That distance right there is about 16.5. So to clean up my workspace a little bit, I'm going to erase these blue arrows. I'll erase that too. Now I'm going to come back in and we'll put that 16.5 spacing. So it's roughly here and here and here and here and here. Okay, so let me make sure. 1, 2, 3, 4, 5, 6. Okay, so this isn't a huge change, but what this is doing is giving us a path with a slope that is consistent between our 2 fixed points, the 1067 and the 1061. So what I could do here, and if I wanted to be, really smooth and kind of combine some of my skills from my last exercise and even out some of these ridges and things like that, what I could do is start to, let me place these contours where I want them to cross the path. And I'm going to pause here for just a second because What I have done, if you've noticed, is I actually placed these proposed contours perpendicular to the direction of travel on the path, or I've made them square, so that it's perpendicular to the two edges of the path. And that was intentional, so that there isn't a cross slope on this path. This path is just evenly going down on either side of the path. There's no pitch to it that would be pushing water off to one side. This is the very standard, most basic way of putting a contour across the path. We'll get into a cross slope in just a second, but I want to point this out to you because a lot of beginning students, when they're manipulating grades, their impulse is to try and mimic the old contour as much as possible. And I just want to say that when you find yourself in this situation, pause and think, okay, what am I trying to do here? And the most basic way to make a path kind of stand out from the existing landscape is to treat the contours in this way and make them perpendicular to the direction of the path. So going back to something I was saying before, I could bring in some of my old grading skills, like from the last video, and just even out some of these ridges. So let's just say I decide I'm gonna tie in right here, and I'll connect that across, and maybe because I want to make it more smooth, I'll tie in over there. So here is my new 1066. And it's a solid line, not a dashed line, because proposed contours are always solid lines. And I have written my elevation on the uphill side of that. I could have also written it inline, but I wrote it on the uphill side. So now 1065. I'm going to do something similar. I'm just going to tie in right there. And as I take that across, I'm going to tie it in over there. Here's my new 1065. All right, now on to 1064. Since I said earlier that the little path that we have right here, we're just going to imagine it's going away. I'm not going to worry about it. And I'm going to keep this nice even grading that I have going on. I'm going to tie in over here and kind of keep an even distance with that 1065. Bring that contour across. And this actually isn't terrible over here. I'm actually just going to take my contour right there and tie it in. I'm not opposed to that. And so here is, I'm going to write 1064 off to the side because I don't want it to get kind of muddy in there in between the 1066 and 1065. That's right in the middle of where I would have wanted to put it. So now with 1063, I'm actually going to bring and tie in right there. And I will carry it across and tie right there. And so here is 1063. And then 1062, I'm going to do something similar. Tie it in. And then 1061 I leave alone because I'm not messing with it. So now I've regraded this slope and I have made my contours perpendicular to the direction of travel. Now, out of curiosity, I want to find out what the slope on this new path is. So I'm going to do the slope calculation real quick. So I'm going to change my colors for just a second. So I want to calculate the slope. And I didn't say this earlier, but I should have. Let's assume that I got to bust up this existing concrete walkway, but I had to put it in basically the same place of where it was. So I'm going to draw that sidewalk boundary in this yellow, just so that we're clear that we understand this is still the location of my path. So what's the slope of it? So we know our slope equation. Slope is equal to rise over run. And I also call this delta E, change in elevation over change in length, delta L. You use whichever one you want. So the slope is equal to, and we know from 1061 to 1067, our elevation, we know our rise is 6 feet. And our run, as we captured at the beginning, that is approximately 99 feet. So I'm going to put that in here. Go back to my calculator. 6 divided by 99. That is 0.606. Convert that to percent. And that will make, oh my goodness, I wrote that wrong. I'm glad I caught that. My slope in a decimal is 0.606. So if I'm going to make that percent, that's going to move my decimal over 2 places. So that is a 6.06% slope, which I'm going to round to 6.1%. Which is great. That means it's ADA accessible. Not that that was a condition of this particular problem, but always good to kind of think about percentages that are ADA accessible. Okay, so I'm going to move to a clean slide now. Okay, and now I want to talk about placing contours on a new path where maybe it isn't so straightforward or so clear. And for this one, I am going to focus on a different path and some existing contours that are on this site. I'm going to focus on the path that is immediately west of what was the old McCain. Of course, it's getting torn up now. But let's assume this isn't getting built over, and the university has said, okay, we would like you to still keep a path here, same width, all of that stuff, and I'm going to mark it in yellow right here. But we're going to eliminate this retaining wall that has been holding up the soil on the westmost side, and we want those contours to come across the path. So in case you didn't notice, there was a little bit of a shape here. That's the retaining wall. And then these contours, those are where they're all meeting the wall. Now, this is not exactly a perfect base map, but we're going to go with it because it's what we got. So instead of having those contours dying into that retaining wall, we're going to ease out the slope and have those contours move across the path. But the university has also said, please provide a cross slope. Oops. And what they actually want us to do is to drain to a new catch basin that I'm going to tell you about right now. Now, of course, we don't have to deal with catch basins in our ENVD problems, a yard inlet, a drain, whatever you want to call it. It's just part of the situation of this problem. But as you may recall from the last video, there's a little bit of a swale signature happening right here. And when we showed the university that we could regrade this to make this even more of a swale signature and really capture any water on site, they said, oh, you know what, that would be great because we have an ability to put in a catch basin right here that we would love to install to capture water that is flowing through this area that has previously been pooling around, and we just want to convey it elsewhere. So we're going to put in a new catch basin. So please, while you are regrading this path, also do that really nice swale that you put in, that simple swale, and we will drain all of the water down that swale into here and off this pathway to be captured and flow into our catch basin. And we say, yes, of course. Sign this contract right here. So now, how are we going to do this? So the first thing that we're going to think about is what our elevations are, because I learned the hard way, it's always a good idea to label things that aren't really clear before you start, because you'll probably pay for it later. So we already know 1066 and 1065 are marked, but I'm going to go ahead and mark, let's see, 1064, 1063, 1062, and we know this is 1061. Okay, so what I'm going to go ahead and start out with saying is 1061 is really close to the bottom of this path, and I'm going to go ahead and say that I'm going to have 1061 somewhere about there. And then I look at the other end, the extent that I can work, and it looks like I've got 1065 right about there. Okay, so just to be really clear, this is 1065, and I don't think I need to mark 1061. So, got that. Now what I need to do is kind of like the last one, figure out the distance between each of my contours. And I know that I'm going to have 1, 2, 3, 4, 5. 5 divisions there. So, okay. 5 foot is equal to my rise, or my change in elevation. And now I'm going to go back to my nifty WAC scale, my graphic scale, to figure out what that distance is between my 1061 and my 1065. So I'm going to use my, very precise fingers here, holding them wide. And I'm going to go, okay, so that's 48 to about there. And then that distance is roughly, I'm just going to call that 24. So 48 plus 24, 68, 72 feet. Yep, that's right. Oop, undo that. Didn't want to do that. 72 feet is equal to my run, or my delta L. So if I'm going to do this evenly, let's just see what's going to happen. So I'm going to divide 72. So what's the distance between contours? So that would be 72 feet divided by 5 feet. And I can't do that in my head at this hour, so I'm going to use my calculator, 14.4. All right, so if I look at my nifty graphic scale down here again, and I want to figure out what 14.4 is. If you recall, this is 18. 14.4 is probably somewhere around there. So again, going to use my nifty measuring fingers and go, okay, so my new contour intervals are probably going to be something like that, 2, 3, 4. Let's see. 62, 63, 64, 60. Oh, did I get that wrong? 1062, 1063, 1064. Oh, I did something wrong here. Let's go back. 1, 2, 3, 4. 1, 2, 3. Oh, I was wrong. I caught my error. It's 4 feet in rise. Okay. You guys probably saw that before me and were like, what is happening here? If so, excellent. And I don't know why I needed to divide that. 72 divided by 4 is 18. Let's try this again. Oh, but hey, you know what's nifty about that is that I already have that 18 marked in my graphics scale right here. So that's just a really easy adjustment for me to capture that distance. All right. Let's see. So it's about like right there, I think. Nope, it's a little bit too far. About right there, I think. 1. Yeah, something more like that. It's close enough. So now, with, I know that that's approximately where these contours might meet in right there to get that slope. Now, quick question before I commit to this is I want to know what that slope actually is. So let's do this as a calculation. So what is that slope? So now I go back to my rise and my run, which I have over here on the left side of my page. So my slope is equal to 4 feet over 72 feet. And that is equal to 0.0555. It goes on and on. So I convert that to a percent. Oops. Times 100%, and that gives me a slope of 5.6%. I'm just going to go ahead and round it up right now. Also great, because I want this to be ADA accessible. Oh, but there is a problem. I just reread the letter that the university said to me. They sent asking about this, and they said that the maximum slope on this walkway has to be 5%. Oh, okay, so I've got to make an adjustment. But before I do, I'm going to put weight. The maximum slope is 5%. Okay, so we're going to stop here and go, all right, where's my wiggle room? And my biggest wiggle room at either end of this to figure out how to adjust my contours. Let's see, is it down here? Well, no, because this walkway is tying into a bunch of other walkways that are coming into it. I don't exactly, I want to kind of keep what's going on here. I'm going to think about that, but that's a little bit tight. Up here, I could potentially, squeeze this point down, or this contour where it's tying in a little bit down. I guess I have that. But I'm thinking this through a little bit more, and I'm realizing I forgot that the university has asked us to put in a cross slope to drain there. And because, water always travels perpendicular to contours and the closest distance between them, if I'm going to drain here, that means my contours across this walkway are going to be angled slightly to be pushing that water in that direction. So again, I'm thinking this through, and I'm thinking if I were to have put my contour like this, that's going to create a much closer proximity right there, a change in elevation of a foot over a pretty short distance. And I'm actually not okay with that after all. So what I need to do is actually I'm going to keep that placement of 1065 right here, and I'm going to know that this 1061 is flexible. I've actually got to determine that location. So I'm going to erase that for right now. Oh, let me bring my screen back. Okay, so now I have 1065, and I know I've got a change in elevation of 4 feet. That is not changing. But I can change the distance that we drop that 4 feet. And I know that my maximum slope has to be 5%. So what I need to figure out now is the run. So let me set up a new equation. So my slope is 5%. But because I'm now doing math, I'm going to convert it back to that decimal. 0.05 is my maximum slope. My rise is still 4 feet, but my run is what I need to solve for. So my run is going to be 4 feet over 0.05. I'm going to bring up my calculator again. 4 divided by 0.05. So my run is equal to 80 feet. Well, actually, I am in a little bit of a pickle. Let's see what 80 feet would be. Okay, I'm going to go back to my graphics scale. And I'm going to go to my 48. So I already know that this distance is 72. That would add another 8 feet. So that's going to have me going down here. You know what? I think what I'm going to have to do for this problem is just assume that I'm going to push this up a little bit further. I think I was hoping that I had some other sort of wiggle room, but I was wrong. So what I'm going to do is I'm just going to push this pathway up a little bit further. And we're just going to say, because I can't change it very much now, that, let me change my colors here. Up here is going to be the new 1065. And let's just say that approximately, let's see, we got 48. That would be 96. Let me make sure that's right there. 48, 96. So I need to go somewhere. It's going to be right around here. That'll be my 1061. So now what I need to know is what is the distance between those contours, so I can go ahead and start marking them where they intersect the path. So now I'm going to do a new calculation. So just like over on the left-hand side of the page where I was asking what's the distance between the contours, I'm going to do that again. Distance between contours is equal to 80 divided by 4. That's 20 feet. Okay, so now we're going to mark these. Going to get rid of my old marks. All right, so I'm going to go back to my graphics scale, and I know that 20 feet is about right there. So 1, 2, 3. Oh, I messed that up a little bit. I could also just divide it into fourths if I needed to, like divide it in half and then again. So there's my new contour locations. Now, again, like I said, the university is wanting us to have a little bit of a cross slope. And so up here, I'm going to start at 1065. Now, you actually can calculate how to, where that cross slope will actually cross, how shallow or deep that angle of crossing is. That's outside the scope of this project. So just for right now, I'm just going to fake in a cross slope. Now, there is a little bit of finesse here at the bottom for this 1061, where it's going to start coming in to meet this existing walkway here. So I don't necessarily need it to be as deeply angled of a cross slope right here. I can start to kind of ease up on that cross slope a little bit. Also, I'm pretty much past that catch basin. Like, it's not going to go in there unless I were to, angle the walkway somehow like this way, which would be crazy. So what I'm going to do for this last one is I'm going to actually ease up on that angle just a little bit. So now just thinking about going back and making sure that I've got the nice swale that's leading to it. I'm actually going to start down here closer to my catch basin, and I'm going to regrade what's happening. Well, first I'm going to start with 1061, and I'm just going to tie it in like this. It's just going to kind of wrap around that catch basin. So for 1062, just as a reminder, the signature for a swale is for it to kind of loop up like the letter N towards the uphill side. So I want a little swale that has kind of like in line with its center line is going to lead directly to that catch basin. So I've done that, and then I can come back here, tie there, and let's just assume this ties in somewhere right there. So there's my 1062. I want to keep that swale signature happening, and maybe that was a little bit too sharp. Maybe I can make it a little bit broader and more gentle. And then come up and tie into that. Let's just say it ties in right over there. Let's just say I want to make this even more gentle. So I'm going to do that tie-in right there instead. And then continuing up to modify 1064. Tie it in like that. And maybe even that out just a little bit so it ties in right there. And then with 1065, I'm going to tie it in right there. And then it'll go like that. So if I wanted to make this way gentler, like a broad, wide swale, I could, of course, stretch these swale signatures out a little bit more. I've made these kind of ditch-like the way they are. So let's just say I've done this and I've decided, you know what, I think it needs to be more gentle. I can just come back here and start and just do this again. It doesn't take that long. And I do this all the time. This is just the process of landform design. Is you do something and then you take a look at it and you realize that maybe you can be even gentler with how you're treating the landform. And then you're creating something that may not even necessarily read as a swale after all. Maybe even too, I decide that This could even be gentler how it's tying in to the path. So it might just very gently come and tie in like that. Now, of course, I'm leaving a little bit of mess here doing this on an iPad. I can just clean that up. Of course, if I was drafting this on paper, I would neaten that up really nicely. Okay, so now what that has created is basically a swale center line. You don't have to use this for ENVD, but that is a symbol that we use for swale center lines. So now I know that my water is draining down this grassy area, into the catch basin, and that it is also draining off this walkway like this, and will hopefully be captured in that catch basin as well. So that's it. Thank you for following along with me and with all of my math errors, but you know what? We pay attention while we do it and we catch them. And if you have any questions, of course, you can reach out to me, excuse me, or your ENVD professor, or of course, one of your peer educators that would hopefully be very happy to help you out with this. Thanks again, and happy grading.